Find the volume of the region bounded above by the sphere of radius square root of 2 and below by the paraboloid x square plus y square. So this one is the paraboloid x square plus y square, and the one below is the sphere, and they intersect over some region. And what is the volume bounded by these two? So we need to find the intersection first. If we try to find a common solution, find the intersection, it will give us the region of integration for the volume. For common solution, I will replace x square plus y square with z in the first equation. So it will be like z plus z square is equal to 2. Just replace this x square plus y square with z from the paraboloid equation. Now this is a quadratic equation, which is easy for you. Z square plus z minus 2 is equal to 0, and z plus 2 times z minus 2 is the correct factorization. So z is either -2 or 1. This is not the case because x squared plus y squared will not be negative. Z is equal to x squared plus y squared. So they intersect on the plane z is equal to 1. The intersection is actually z is equal to 1 and z is equal to x squared plus y squared. So it is going to be the unit circle on xy plane. So for the unit circle, we may directly say the bounds for r and theta are going to be r is from 0 to 1 and theta is from 0 to 2 pi, because we have all the possible theta values here, 2 pi. What about the z coordinate? Z is between, it is bounded below by the paraboloid x squared plus y squared and above by the sphere of radius square root of 2. So z is, for the sphere, it will be square root of 2 minus x squared plus y squared. From this sphere equation, if you express z, it is going to be 2 minus square root of 2 minus x squared plus y squared. But we have to express it in terms of cylindrical coordinates. For cylindrical coordinates, x squared plus y squared is r squared, and similarly here, x squared plus y squared is r squared. So these are the bounds for z. So the volume is going to be the triple integral in cylindrical coordinates, triple integral of 1 dv over this region over d. That will give us the volume of the region. If you remember, dv is replaced with r dr d theta dz, or you may change the order as it is necessary. For this one, z will be the innermost expression, and then you may say r and theta. R is from 0 to 1, theta is from 0 to 2 pi, and z is from r squared to square root of 2 minus r squared. We have 1 dv is replaced with r dz dr d theta. We have to use the same order. Z here, r, the bounds for r 0 to 1, and for theta it is 0 to 2 pi. So if we start with the innermost integral, we have r, so it is r square over, let me use r square over 2. R is from, sorry, we integrate with respect to z. So integrate with respect to z, it will be rz, and z is from r squared to square root of 2 minus r squared. So this is r times square root of 2 minus r squared minus r times r squared, which is r cubed. This is the result of the innermost integral. Now move on to the next step. Integrate with respect to r 0 to 1, and we will integrate this integral 2 minus r squared minus r cubed. So we will use some substitution for the first part. So let's just split it into two integrals and calculate separately. The first integral is 0 to 1 r square root of 2 minus r squared dr, and I will say u is equal to 2 minus r squared. The u is negative 2r dr, and when r is 0, u is 2. When r is 1, u is 1. So it will be 2 to 1 integral from 2 up to 1. Square root of 2 minus r squared is u to 1 over 2, and instead of r dr we may write negative du over 2. If you want, switch the orders and get rid of the negative here. So up to you. If I say 1 to 2, u to 1 over 2 du, this will be fine. 1 over 2, integrate u to 1 over 2, 3 over 2 over 3 over 2. U is from 1 to 2. So simplify these 2's here. For 2, we will get square root of 2 to 3, which is, let me write 1 over 3 first. 2 to 3 over 2 minus 1 to 3 over 2. 2 to 3 over 2 is square root of 8, which is 2 square root of 2, and this one is 1. So if I continue with the next one, the result of the integral from r is 2 square root of 2 minus 1, 1 over 3, 2 square root of 2 minus 1, and we will integrate this with respect to theta. Theta is from 0 to 2 pi. So this is going to be 2 square root of 2 minus 1 over 3 multiplied by 2 pi. For theta, 0 will give us 0, 2 pi will be this one. So this will be the volume. Unit cube is the volume between that sphere and the paraboloid, bounded above by the sphere, volume between sphere and the paraboloid. So we used cylindrical coordinates and calculated the volume between these two curves, sphere and the paraboloid, and it turned out to be this number, 2 square root of 2 minus 1 over 3 times 2 pi. Please visit the website for a categorized list of my YouTube videos. It is given below in the definition of the video. Subscribe and like.